Hey everyone, how's it going? So today's video we're going to be going over a Maths Paper 2 paper, and it's from last year, November 2022. And it's the matric final paper for IEB. So as always, got to make sure we check the instructions. So in this case, the two instructions I want to highlight is very important for paper 2, especially paper 2s. Make sure your calculator is in degree mode. We covered that in another past paper. I will link to that past paper, but always make sure that it's in degree mode. So if you don't know how to put your calculator in degree mode, or you just need a reminder, you should be able to see the video somewhere here in the top right, and you can click onto that, and you can see how we did that in the previous video. And secondly, another thing I want to highlight is the instructions say we need to be rounding to 1 decimal place. So always make sure you check the instructions before you start. They are important. And also a bit of a side note, always make sure that your paper is complete. So if they say this paper consists of 16 pages, make sure in your reading time that you do have 16 pages rather. And yeah, let's get into it. So paper 2 contains the statistics work, the geometry, Euclidean circle geometry. It contains the proportion things, the triangle things, all of those things, a lot of things, and the trigonometry. So this paper tends to be quite triggy. Okay, sorry, bad joke. But yeah, there is trig in this paper. A lot of the students do find that quite tricky or triggy. But I hope at the end of the video, things will be a bit more clear. I probably will be making some more in-depth videos on, or maybe I already do have some lesson videos on some of the topics we're going to be touching on today. So let's get into it. Here we have a jewelry manufacturer, and they measure the diameters of 400 gold spheres. So we got 400 gold spheres here, produced by machine A, and another 400 produced by machine B. So there's 400 of each, A and B. And you'll see here, here's A, and here's B. So the curve in red is our B. So the results are represented in this cumulative frequency curve shown below, both of them. So it's also known as an ogive. They give it over here. Let me change colors. They say cumulative frequency or ogive. So ogive is a lot easier to say than cumulative frequency. I'm struggling with that today. Sorry. So this is what we have going for us. And is there anything important? So we've got the cumulative frequency. They both end over here at 400, which makes sense because there's 400 spheres of each. And we get the diameters in millimeters over here. So cool, let's jump into the question. For question 1, it says determine the interquartile range. We're going to have to determine the interquartile range for the diameters of gold spheres produced by machine A. So very important, it's this blue curve over here. So the blue curve is machine A. So we need to be determining the interquartile range. So interquartile range just means we're going to take our third quartiles, Q3, minus Q1. So that'll give us our interquartile range. So we know our Q3 will be at, in this case, it'll be at 300. So if we have 400, if we divide it into quarters, that's 100. So our Q1 will be here at 100, our Q2 will be here at 200, and Q3 at 300. So if we track this across over here, you don't have to show this in your exam paper, but I'm just doing it for us. So we get that Q3 is equal to 6,0 millimeters. Okay, and if we do Q1, we look for Q1, it'll be here by 100. And remember, we're working with the blue graph because I say machine A. So we'll see here it's 5,8 millimeters. 5,8 millimeters. Okay, so our interquartile range, or IQR, is equal to 6,0 minus 5,8. So if we do that, we're going to get 0,2, don't forget your units, millimeters. So that's our interquartile range. For question 2, it says determine the 50th percentile for the diameters of gold spheres purchased by machine A. So the 50th percentile is just where it's halfway between. So the 50th percentile. So this is just another way it's essentially another way of saying the median in this case. The 50th percentile. So we know there's 400. So 50th percentile will be here at 200 because that's 50% of 400. So 200. So just like we did before, we're going to track across here. And we're still working with machine A, so it's the blue one. And if we track down, we'll find that the 50th percentile is 5,9 millimeters. Okay. It says now for question 3, if the gold spheres with diameters less than or equal to, so this is very important. So very important, less than or equal to 5,9 millimeters. So that equal to is very important. So if these gold spheres with the diameters less than or equal to 5,9 millimeters are considered defective, determine the percentage is important here, of defective gold spheres produced by machine B. Okay, so there's a lot going on. So let's break this into steps. This will be step 1 and this will be step 2, this percentage part. So we need to find how many gold spheres have diameters less than or equal to 5,9 millimeters. And we're working with machine B, so in red. So we go to 5,9 millimeters, which is here, 5,9 millimeters. And we need to work out how many have 5,9 millimeters diameter or less. So we need to work out everything, all of the numbers over here. So what we do is we just track up over here to this 5,9, and then we track across to work out how many spheres have 5,9 or less. Because remember, not all of them, there's not 100 spheres with 5,9 because this is a cumulative frequency. So there's points over here, and it's just how many have 5,9 or less. Because if you'll see here, if you tracked across here, this many had 5,8 or less, but here 5,9, 100 have 5,9 millimeters or less. That's how we track that up over there. Went a bit off topic there, sorry about that. But there we go. So we know it's 100. Okay, so we know there's 100 gold spheres. Okay, you don't have to write this in your test. This is just, let me put a little star here. This is me just thinking out loud, I guess. So we know there are 100 gold spheres that have a diameter of 5,9 millimeters or less. Okay, so that's what we just found out. But the question is asking, it wants the percentage of defective gold spheres. So we know 100 will be defective because this is defective. So I'm just going to write def for defect. So we know there's 100 defective gold spheres, but machine B produces how many? If we look up here, and it said on the previous slide, machine B produces 400. Let me fix this, 400. So machine B produces 400. So there's 100 defective out of 400 total produced. So if we evaluate this, we'll find that it's 25%. Okay, not too bad. So here we have a box and whisker plot. It says in a school, learners were surveyed about the time they spent on the internet over a weekend. The results were displayed by a box and whisker plot as shown below. First question, is the data positively or negatively skewed? So to remember this, sometimes students get confused with this. So you need to remember this. Things will be negatively skewed. So negatively skewed is the same thing as saying left, skewed left. Okay, so it will be negatively or left squared when the mean, so when the mean is less than the median. Okay, and let's have a look how that plays into practice here. So we know from our box and whisker plot theory, this is Q2. This is Q2. And you can see how long this is. You see how long this part is over here? It's much longer than this part over here. You see the part in the green on the left here, it's a lot bigger than this box on the right. So they represent 25% of the data, all right? So there's 25% here in the orange. So just to be clear, from there to there is 25%. And then from here to here is also 25%. But the thing is, you see how these go from a very low 2 all the way to a 5. So the difference between there is 3. And over here it goes from 5 to 6. So you see how there's a lot of leeway. There's low numbers over here. So what actually happens is because this is longer, the mean will be somewhere over here. So the average will actually be to the left. So your average will be somewhere over here to the left. So if that is the case, then we have this over here. Because the mean is to the left of our median, then we will be skewed to the left. So if the mean is on the left, then it's skewed to the left. So in this case, it's skewed to the left, but another word for that is negatively skewed. So our answer here would just be negatively skewed. And for some reason, I've repeated that question, so don't worry about this. We just answered that. And I've given the box and whisker plot up there on the right if we need to refer back to it. And question 2, consider the statement given the percentage. Okay, that's important. So they're talking about it, percentages. The percentage of learners that spent from 2 to 5 hours on the internet is almost 3 times as much as the percentage of learners that spend from 6 to 7 hours on the internet. Is the statement true or false? So let's break this down. So 2 to 5, here's 2, and here's 5. So it says the percentage of learners from 2 to 5. Well, we know this is just from Q1 to Q2. We know this is just 25%. So we know 25% of our data lies between here. Then it says this 25% is almost 3 times as much as the percentage of learners that spend from 6 to 7. So let's get this in another color. Here's 6 and here's 7. Well, we know that this is also just 25%. So we know the percentages are equal. So it's not 3 times as much as that they were saying here. So in that case, the statement's actually false. And it's just as easy as that. So for question 3, it says one of the learners was not included in the data represented in the box and whisker plot above. If the learner spent 10 hours, so they spent 10 hours on the internet over the weekend, then determine whether the learner is an outlier or not. So we have to use this formula over here. So Q3 plus 1,5 times IR. So this formula will say if anything outside of this range would be an outlier. So this formula will tell us if anything is an outlier. So this formula tells us any outliers. So we need to apply this formula. And we know our Q3, we can look up here, our Q3 is 6 over here. Our Q3 is 6. So we're going to get 6 plus 1,5. And our IQR, we solved all the way over here in question 1. So we got our IQR to be this, 0,2 millimeters. So we do that. And if we put that in our calculator, we're going to get that this is 12. So what this is saying, anything bigger than 12 will be an outlier. So if we look over here, imagine this continued 12, anything to the right of this 12 will be considered an outlier. But we were talking about the student that was left out, which was 10 hours. So you see how 10, you can say here that 10 is less than 12. So then you can say we had to determine whether the student is an outlier or not. So then you can say, therefore, student is not an outlier. Okay. Now we're given this quadrilateral. It says the point A is given -310 and B in the first quadrant are points on the quadrilateral ABCD. So we can see that all the information there is given. Then it says equation of line DC, so that line at the bottom is given by this. So this is obviously quite important. We're going to make sure you highlight it or don't forget this information on your exam paper. All right, let me fix this box. So it says DC forms an angle theta with the x-axis as indicated. So here's theta. All right, so if we ever get stuck, remember, come back to point 2, because point 2 has information that's not on the diagram. So always remember that. So I've given the information there in the top right for us again. And now for A, it says determine the size of theta. So what we need to be doing is we need to be using our formula that says tan theta. Let me fix that theta. Tan theta is equal to m. We need to be using that formula. So we're trying to find theta. So we're trying to find this. We're trying to find this theta. So we need to think, what do we know? So we have to know this gradient. That's what this formula is hinting us at. But let's just check. Do we know this gradient? So theta lies here. So we need to know the gradient dc. And we do know the gradient dc. It was given here in this point over here, 0.2. We know the gradient is this in front of the x. So we know the gradient is negative 1 over 3. So I can write tan theta is equal to negative 1 over 3. So if I do my shift tan theta there in my calculator, making sure we're in degree mode. So if I do that in my calculator, I get negative 18, 4 degrees, okay? But the angle can't be negative. The thing is, normally what we do is we normally measure. So if I draw something like this. So normally what we do is we measure theta this way. We measure theta, what's this, anti-clockwise. But you see here, we're measuring theta this way, clockwise. And because we're measuring it clockwise, that's why it has this negative in front. So our real answer is just theta is equal to 18, 4 degrees. Now they say we have to determine the equation of the line AB if AB is parallel to DC. So very important, parallel lines just mean the gradient of AB is going to be equal to the gradient of DC. That's what parallel lines mean. So we've already got this sorted for us. So we know what the gradient of DC is. It's just this thing over here. So we'll have that the gradient of AB is equal to the gradient of DC, which is equal to negative 1 over 3. So we have that now for AB. And we can use this equation. We can say y minus y1 is equal to m x minus x1. We can do this now to find the equation. So we need to substitute a point on the line AB, and we have this point over here for A. So we say y minus 10 is equal to minus 1 over 3, and we put our x, normal x, and now what we do is we say minus negative 3. So that becomes a positive. And when we solve for this, we get minus 1 over 3x, and this will become minus 1, that's plus 10, so this will be our final form, so our final answer. Now we have to determine the equation of the line AD if AD is perpendicular to DC. So we need to find the equation of this line AD. So, and we know AD is perpendicular to DC. So when lines are perpendicular, we have this. We have that the gradient of AD times the gradient of DC is equal to minus 1. So we don't know the gradient of AD, but we do know the gradient of DC. That's just minus 1 over 3. And we know this is equal to minus 1. So when we solve this, we're just going to be getting that the gradient of MAD is equal to 3. So we know this gradient is 3. And then just like before, we just substitute a point, and we're actually just going to substitute the same point, just using this formula. I'll write it again for us. So we're just using this formula again. So y minus 10 is equal to our gradient is now 3x minus x1, and our x1 is minus 3. So minus minus 3 gives us plus 3. So we get y is equal to 3x plus 19. That's our final answer. So this is the equation for AD. Now they ask us for the coordinates of D. and hence calculate the length of AD. So we need to find this coordinate D. So we know the equation of this line, AD, and we also know the equation of DC. So the equation of line AD is, I'm going to write it here for us. So AD, equation of AD was, we just calculated, was y is equal to 3x plus 19. And the equation for DC is, it's given up here. The equation of DC is this. So DC is equal to y minus 1 over 3x minus 1. So those are the equations. And here's AD and here's DC. And what's special about this point D, it's the point of intersection of these two lines. So it's a point of intersection. So if we set these two equations equal to, we'll be able to find this point of intersection D. So we'll set these two graphs equal to each other. So we have 3x plus 19 is equal to minus 1 over 3x minus 1. And here we can just multiply everything by 3. That'll help. Actually not. Let's just do this. Let's just take the different things across like this is equal to negative 20. So this is what we've got going for us. If we add those together, what we're going to get 10 over 3x is equal to negative 20. And now what we can do is we can multiply by 3. So 10x is equal to negative 60. So x is equal to negative 6. So we have the x coordinate of D. So we know D is going to be minus 6 something. We don't know what the y value is. But now what we can do is we can just take this x value and plug it into either one of these. So we can put it in there or there, and we'll find our y value. So let's do that. If we do that, we get y is equal to 3 to the negative 6 plus 19. So that's negative 18 plus 19, which is just 1. So we know the coordinates of D are negative 6 and 1. So those are coordinates of D that we have now. So we've got this first part, we got the coordinates of D, but we have to calculate the length of AD. So we're going to have to use our distance formula. And I shall continue up here for us. So we know that AD, that looks terrible. Let me fix this. So the distance of AD is just given by the distance formula. So what we do is we say, let me write out the full distance formula for us. So x2 minus x1 minus x2 squared plus y1 plus y2 squared. Let me fix this. This should actually be a minus in between here. Okay, and all of this is squared. Sorry, it's a bit messy. I'll sort it out now. All right, so got the square root. Let's choose our x1. I'm going to choose this as my x1. I'm going to be saying minus 3 minus 1 squared plus, and now remember I have to choose, I chose this x first, so I have to choose this y first as my y1. 10 minus 1. And I actually messed up here. This should be minus 3 minus minus 6. So sorry if you were screaming at the monitor and typing an essay in the comments. Hopefully I sorted that out before it got to that. But anyways, if we evaluate this, we're going to be getting that square root of, this is going to be minus 3 squared, so that's just 9. This is going to be 9 squared, that's 81. So it's going to be the square root of 90. Square root of 90, and if we put that in our calculator, that's just going to be about 9,5 units if we round to one decimal place. So that will be the length of AD. Now for the second part of this, it says it's further given that the equation of line BC is x is equal to 6. So it's saying that this equation is x is equal to 6. That's the equation of this line over here. And it says, show that ABD, triangle ABD, is an isosceles. So ABD, it looks like this. So it says show that this is an isosceles. So a good bet would be that these are equal. So remember the theory of an isosceles, it's just a triangle that has two opposite equal sides. So these two look like they're about equal. So, and also the question guides us because here's AD on the left. And in the previous question, we just worked out AD. We just worked out this AD. And now they're talking about an isosceles. So we already have AD. Okay, so see, have a look here. This is part 2 and this was part 1. So it kind of guides us that we have to use AD over here. And we're also going to have to use AB. All right, because if they're equal, then it's an isosceles triangle. So we need to find the distance AB. The problem is we don't know the coordinates of B, but we do know that the x value of B is 6. We just need to find the y value. And that's not too bad because we should have already calculated the equation for AB, the equation of line AB. I'm going to pull that up for us. We got the equation of line AB here in part 2. So this was the equation for line AB. So let's write that in. We're going to need it. So we have y is equal to negative 1 over 3x. Let me double check, plus 9. So this is the equation for line AB. So let me add that in. This is for AB. So we have the equation for line AB and we know the x value. So we do know this x value. So we can determine the y value of B. So if we plug this in, minus 1 over 3 x plus 9, that gives us what? Negative 2 plus 7. Sorry, negative 2 plus 9, which is 7. So we know the coordinates of B is 6, 7. Sorry about the different colors there. But yeah, 6, 7. Those are the coordinates of B. So now we can find the length of AB. So again, we're just going to use the distance formula. So AB is equal to square root. I'm not going to write out the formula for the distance formula again for us. I'm just going to go into it. So we're going to have minus 3 minus 6 squared plus 10 minus 7 squared. And then all of this is square rooted. And if we evaluate that, this is minus 9 squared, which is 81, plus 3 squared, which is 9, obviously. And again, this is going to be square root 90. So this is going to be equal to approximately 9,5 units, like we did before. And which is also equal to a D from the previous question. So we've shown this, but very important, you can't just stop now, all right? Because we have to show that it's an isosceles. So you have to say, therefore, triangle ABD is isosceles. For question 3, we have that the test scores of 5 students are given in ascending order as, and then they give us a bunch of things over there, 25, x plus 3, x plus 6, x plus 9, x plus 13. And they say that the median is 41. So we know what Q2 is because the median is Q2, sorry, Q2. All right. So, and the data is given in ascending order. So this is important. So the data is already grouped. It's already been organized in ascending order. So we have 1, 2, 3, 4, 5. There's 5. Oh, it's it up here. So there's 5 students. And so we're given 5 students. And we know that the median will be in the middle. So it'll be the third value over here. So there's 2 to the left, 2 to the right. So we know that the median is x plus 6. But they say that the median is 41. So we know that this is equal to 41. And we need to determine the value of x. So we just take that 6 to the other side and we get x is equal to 35. So we've determined the value of x because that's what we needed, the value of x. Now it says determine the standard deviation of the scores using your answer to A1. So let's actually work out everything we have here. So I'll put this on the next slide for us. So here's all the data. The way I figured this out is every time I saw an x here, I now replace this with 35. So 35 plus 3 is 38, and then I just did that for all the other ones as well to now get this data. Because we need to actually know the values to determine the standard deviation. So we just need to put this in our calculator. We don't have to do anything fancy. So we go to our calculator, go to stat mode, and I have another video, I'll link it here on the right, top right, where I go a bit more into the stat mode. So if we put these values into our calculator, we go to mode 3 for stat, and we only have one variable, so we press 1 for one variable. And we put in our x values, 25, 38, 41, 44, and 48. So there's 5 values. They're all entered now, so we can press AC. We go shift 1 for stat, and we're working with variance. So we press 4 for variance. Press 4, and this gives us a bunch of things. So we need sigma, because sigma is standard deviation. We press 3, this will give our standard deviation, and we find that it's 7,8. So here we can just write that the standard deviation, or sigma, is equal to 7,8. The next question says how many scores, so important how many, will lie within one standard deviation from the mean. Show you're working. So we know the standard deviation. So we know what one standard deviation is. We've just worked it out in the previous question, but we don't know what the mean is. We haven't worked out the average. So let's work this out. So we can use our calculator again. So let's do that. Let's use our calculator. Let's bring it up. And so we know what our standard deviation is. So we can just go back down here into variance, and we can use X bar to give us our mean. So if we work this out, we find our mean is 39,2. So let's write that down. We know that our mean is equal to 39,2. So we know our mean is 39,2. And from the previous question, we know our standard deviation is 7,8. So to determine how many scores lie within one standard deviation, we have to determine this range. So what we do is we're going to say the mean minus the standard deviation. So if we put that in our calculator, we say, let me write it out. So the range is going to be 39,2 minus one standard deviation, and until x. And here we're going to say 39,2 plus 7,8. So if we put that in the calculator, 39.2 minus 7,8, 31,4. So this is 31,4 x up until 47. So this is just the mean. Let me do this in another color. So over here, we just have the mean plus the standard deviation. And here we just have the mean minus the standard deviation. So we need to determine what's how many fall within. So important word here, how many fall within. So how many fall within 31,4 to 47. So if we go back to our data, what falls in this one, so what falls in is just anything from 31,7. So this will fall in, this 38 falls in, and this 41 falls in, and this 44 falls in. And what doesn't fall in is this 48 because it's bigger than 47. And also this 25 doesn't fall in. So let me do this. This 25 doesn't fall in because it is out of the range here. So the 25 will fall over here. So that's why it's not in. And the 48 will fall somewhere over there. So that's why it's not in. So to answer the question about how many, 3 scores will fall in within. Here we have the minimum overnight temperatures. So it's temperature in degrees C, and the number of service calls, that's S, made to a company that supplies gas heaters was recorded for a period of 8 days. So the equation of the least squares regression line for the data is given as S is equal to negative 1,8t plus 22,7. State whether data represents a positive or negative correlation. So this is just a straight line equation. So if we draw our Cartesian plane, this thing's going to be negative gradient, and it's going to cut the y-axis somewhere positively, so it's going to look like this. So let me do another color. We know it's going to look something like this, and the gradient of this is negative, so we know it's going to be a negative correlation. So here we just say negative. Now we need to use the regression line to predict the number of surface calls made for an overnight temperature of 10 degrees. So we know what the temperature is. We know what this is, the T. So we can just plug that in to determine the number of surface calls. So we're going to say that the number of surface calls is equal to negative 1,8 T, which is now 10, plus 22,7. And if we evaluate this, we're going to be getting 4,7. So obviously you can't get 4,7 calls. So I'd recommend we round down here. So I would say 4 calls. So that would be the estimation or the prediction. If the overnight temperature is 10 degrees, there would be 4 calls. For question 3, it's given that the correlation coefficient for the 8-day period is negative 0,95, so that's R. It says on the 9th day, the number of surface calls was 8, and the minimum overnight temperature was 3 degrees. If the 9th day data is included, what effect will it have on the correlation coefficient? Explain. So if we look at our normal equation for the surface calls and temperature, it's given over here. So I'm going to rewrite it for us. S is equal to negative 1,8 T plus 22,7. So if we plug in our T over here, because remember this is our T and this is our S. So if we plug that in, we're going to get negative 1,8 times by our T of 3 degrees plus 22,7. If we put that in our calculator, we'll be getting 17,3. So 17 rather. 17,3. So that's what we should have been getting, but we got how many? 8. So this doesn't agree with our previous correlation. Because it doesn't agree with our previous correlation and it's off, our correlation is going to be weaker. So if we look at our correlation coefficient, we got R is equal to negative 0,95. So this is a very strong negative correlation, okay? But our data says we should have been getting 17 calls, but we actually got 8. So do you see how that 8 is far away from the 17? So what's going to happen is our correlation is now going to be weaker. So remember, the weakest correlation is R is equal to 0. So we're going to be closer to a 0 because our correlation is getting weaker. So it's going to go from 0,95, so negative 0,95, it's going to go closer to 0. So what's going to happen is, what the effect will be, is the correlation coefficient will decrease, or it will be weaker. So we can say that the correlation coefficient will be weaker. And now for the tricky stuff. So hopefully I can explain it well enough that you guys will see it's actually not that tricky. Okay. So here we're given 2 trig graphs. We're given f of x, which is this blue one. It's this one over here. This fx is equal to sine 3x. And we're also given this red graph, g of x is cos x minus 30 degrees. And it's plotted for x as an element from 0 degrees to 180. So you'll see we go from 0 to 180. Okay, so from here, we can tell a bunch of things already. So if we look at this 3 over here, we know that it's when it's in this position, it changes the period of our function. So it's going to change the period of our f function. And we know that this negative 30, it's going to be shifting our cos graph. It's going to be shifting at 30 units to the right. So it's going to be shifting 30 units to the right. For question A, they say determine the period of graph f. So that's this sine graph over here. They want the period. So I have an equation for this. I'm not sure if schools teach this, but it's something I use and it helps me a lot. So I use an equation that says the period is, so the period for, we know that the period for sine and cos graphs is 360. So this doesn't work for tan, it only works for sine and cos. Okay, so I say 360 divided by, and then what I divide by, the actual equation, let me write the full equation, it's 360 divided by n. Okay, so this n is this number here in front of the x. Okay, so in this case it's 3. So the period is going to be equal to 360 divided by 3. So I get this to be 120 degrees. So that's how I would do it. So even if this was a fraction, say this was 1 over 3, you're going to be saying 360 over 1 over 3. So remember, you just put the coefficient in front of this x at the bottom. So if it was 360 over 1 over 3, so let me show it instead of hand waving over here. So for example, if it was 360 over 1 over 3, then what this actually just ends up becoming is 360 times 3. So 360 times 3. So what is that? 720? The one after that. 1080. So this will end up becoming 1080. So the period will be 1080. So that was just, again, another sidetrack. But I hope that this equation is helpful. You can also look at the graph. So normally, so the period means how long we complete a full wave. So if you look here at f, a full wave, the sine starts at 0, it goes up, and it goes down. Normally, this normally takes 180 degrees. Then this second part also takes 180. So you see how we've gone up, down, and then back up again to where we started. So we started here, went down, and then back up to where we started. So normally this takes 360 degrees for a normal sine, if this was a 1 in front. But here's a 3. So you can see here, it actually, instead of taking 360 degrees, this is now actually taking us, this number over here is 120. And the reason I know it's 120 is because my period is 120. So you could also look at the graph and determine the period from that. In this case, it would have been a bit difficult to see that that was 120. I would have stuck with this equation, but sometimes it falls on nice numbers and you can read off the period directly. Okay, so I hope that was clear. It wasn't too confusing. And now, next question, determine the range of G. So to determine the range of G, we need to have the maximum and minimum Y values. So we can see that the maximum Y value for G is 1. So we know what its maximum value is, but its minimum is over here. We don't know what the minimum is. So don't let this fool you. It's not on -1, so we can't say it's -1. So what we actually have to do is we have to use our equation, this g of x equation, and we need to substitute in our x. Because we know an x, we're trying to find a y. So we're trying to find what this y is. So we can just plug in an x, okay, to find it. So we're going to use this equation. So we will have that y is equal to cos, and our x is 180 minus 30 degrees. And if we put that in our, I often forget these, but remember to put them in, okay? Anyways, when we evaluate this, we're going to be getting that y is negative root 3 over 2. So now the range of our function, we can say that the range is equal to, so remember the range is the possible y values. So we can go from minus root 3 over 2, so from our minimum to our maximum, which is 1. And we put square brackets because we can include these values. So we are 1. So you can have a y value of 1, and you can also have a y value of negative root 3 over 2. So it's not excluded. So that's why it's square brackets, square brackets instead of round. Okay. Now, we have to show on our graph using capital letters, so it's in bold, so it's important. So we have to use capital letters for x is the element from 0 to 180. So they're just saying from 0 to 180, what they've already shown. The solution / solutions to sine 3x is equal to cos x minus 30. So this is just the points of intersection. So we don't even have to calculate the points of intersection. We just need to find where the fx is equal to gx. So the points of intersection. So you'll see they intersect over here. Okay. So the thing is, we don't put an a up here because they want the solutions, the x solutions. Because remember, if you solve this, you're going to be getting x is equal to something. Okay, so we don't put we're not going to put our a up here. We don't put the a up there because we're not going to be getting a y value when we solve this. We're going to be getting an x value. So you would actually have to put the a over here. Okay, so that's our first point of intersection. And our second point of intersection is over here. We can see that they cross over here. So we'll put a b over here. You can also put it below. I didn't put it below because I already put that 120 there. Okay. Now we have to use the graph to determine the solutions where cos x minus 30 is greater than or equal to sine 3x, for x is the element of 0 to 180. So we actually have to determine these solutions. So before we just had to put letters, now we're actually going to have to be saying x is this or this. Okay. So this question is saying where, I'll put our symbols here. This is g of x, and this is f of x. So what they're asking is just where g of x is above or equal to f of x. So g of x is this line in red over here, and we're just looking where it's above. So you'll see here, I like to use a ruler for this. It's a bit difficult to show this over here, but normally when I teach private lessons, I do use a ruler here. But it will be fine. Okay. So you could, normally what I recommend is you put your ruler like this. So you'll have your ruler and you'll see, okay, which one's above? And here you can see gx is above. So that's what I normally recommend, but we won't need that here. It's all good. So if we look here, g of x is above f of x until here, where they're equal. But we can include that. So from 0 to this point A, where g of x is above. Then it's still above, because remember f of x is down here. So it's still above, until this point here where it starts to go below. So we know from this point, remember we have to solve for x values. So we know from this point, let me make it clear. So from here up until here, they're equal until that's when they're equal. So it's above, equal. And here it's above, equal up until here. All right. So because we have this, because of this equal to part over here, we can include this over here, this by this a. We can include this point over here. So we don't actually worry about that in this case because it says greater than or equal to. So we know that from 0, because remember this x is 0, and we're solving for x values. We know from 0 up until this point, g of x is above. So, and we know this point. So the question hasn't asked us what this point is, but because we know our period is 120, we know the graph of fx completes a full wave in 120 degrees. We know that this point over here has to be 120. Okay, so let me write that a bit clearer. We know that this point is 120 over here by b. So we have our values, so we know what's cracking over here. So we know that this solution is true for when x is between 0 degrees to 120 degrees. But you can also write as you could also say or over here. So or. So I'm just going to show you here on the right, I'm going to be showing another way you can write this. You can say x is the element of, and we say 0 up until 120, and we include both because we're allowed to be equal to. So you could say either or of these. I'd normally prefer the one on the right. It's the one I use most often. Now we're getting over to the circle geometry things. So we're given this diagram, and I say A, D, B, and C lie on the circle with center O. So A, D, B, and C lie on the circle with center O. So the information here is so important. So we get a center O. So when we get a center O, we know that OC is equal to OD because these are radii. So OC is equal to OD. So just by reading this information, I already know this. And additionally, ADBC, so ADBC, lie on the circle. So I know that I have a cyclic quad. So I can complete this cyclic quad. Let me show you. If I connect these two, I'm going to erase this in a second, but if I connect these two, I know that I have a cyclic quad. So from A, D, B, C, all the way here is a cyclic quad. And the reason it's a cyclic quad is it just says cyclic quad is just a quadrilateral, so a four-sided shape, where all four vertices lie on the circle. So A lies on the circle, D lies on the circle, B lies on the circle, and C lies on the circle. So we know we have a cyclic quad. So we can also use our theory for cyclic quads over here, which is going to be super helpful. So I'll put a little star here because I know I'm going to have a cyclic quad. And then I'm also given that DB is equal to BC. So that's given here with these two straight lines. So again, just by looking at the information, I haven't even looked at the questions yet. I'm already filling in the diagram and thinking about what I know already, because you're going to have to use this information in these two bullet points to answer the questions. So it's really important that we decipher everything we can in these two bullet points, because if we get stuck in the questions, we always have to look back at our bullet points and see what we missed. And also very important, look back at the previous question. So part A, what did you solve for in part A? Part B, and use what you've already solved and this information in the bullet points to now try and unstuck yourself if you're stuck from the question and you don't know where to go. So look back at what you know, look back at your information. Okay, so this is the first part over here. It says state all relevant reasons with your statements. So that's important. And again, it's in bold. So we have to have statements and reasons. It says if A is equal to X, state with reasons two other angles equal to X. So quickly, we know that OC is equal to OD. So I'm just going to re-add that from the previous slide. And we know that angle A is X. So I'm going to be putting an X here. So state with reasons two other angles equal to X. So I know that ADBC is a cyclic quad. So I can use angles in same segment to determine another angle equal to X. So you'll see, if you look at my other video on cyclic quad theory, I'll put a link here in the top right. You can review that. But we have these spider eyes over here. So let me show you. So over here, we have these spider eyes. I discussed this in that cyclic quad video, and I will link it. But we have these spider eyes that we're about to use to determine angles in same seg. So let's have a look. So if we use these spider eyes, we put our finger at A, and we move across. We touch the circle at C and B, and then we move up and touch C2. And again, if you're a bit confused there, have a look at the cyclic quad video. But I know that C2 is equal to X. So I'll have that angle C2 is equal to X. And the reason is angles in same segment. Okay. And I know that this is X. So let me put that C2 as X. So C2 is X. And because I have this isosceles triangle, I know that D3 will be X. So I can say that D3 is equal to X, and the reason is there that we have isosceles triangles. Now for part B, it's given that O1 is 94 degrees, and we need to determine D2. So this is now 94 degrees, and we have to determine D2. So again, really important, don't forget that these are equal. So we know this angle is 94 degrees. But we also know that this angle is equal to this angle. I should put this in a different color. So I know that D2 is equal to C1. And the reason is because it's an isosceles triangle. So I can work out, I know that there's 180 degrees in the triangle. So I know that I have D2 plus C1 plus 94 degrees is equal to 180. And the reason there's angles in a triangle. So I know that. But I know that D2 is equal to C2. So I have that D2 is equal to C1. And the reason there is isosceles triangle. How do you spell this? Isosceles. That's not it. Isosceles. What is my spelling? I might have spelled it wrong on the previous slide as well. It says isosceles. Isosceles triangle. So now what I can do is I can just say, okay, 2D2, 2 times D2 plus 94 degrees is equal to 180 degrees. And now what I do is I just take that 94 to the other side. So I get that D2 is equal to, so I'll say 180 minus, I'll show it, 180 minus 94 degrees. This should be a 2. But I can just work out D2 by then just dividing by 2 on both sides. So D2 is equal to this over 2. So D2 is equal to 43 degrees. Now I have to determine B1 plus B2. So I need to determine these two angles together. So B1 and B2 is an angle at the circumference. So we know that the angle at the center is equal to 2 times angle at the circumference. So I know that this reflex angle over here, so O2, is going to be 2 times B1 plus B2. So I'll write that first. I'll say that angle O2 is equal to 2 times angle B1. So I should put these together. Angle B1 plus B2. And the reason is angle at center is 2 times angle at circumference. Okay, but I need to determine O2, but I know what O1 is. In the previous question, I said O1 is 94. So I know what O1 is. So to determine O2, I'll just say O2 is equal to 360 degrees minus 94. And the reason there is angles around a point. So if I do that, I'll get that O2 is equal to 266 degrees. So now I can use this equation over here. So I know that O2 is now, so I'm just plugging in 266 here for O2 is equal to 2 times B1 plus B2. And I can just divide by 2 on both sides. So I'll end up getting that B1 plus B2 is equal to 133 degrees. Now it says hence or otherwise determine X. So let's have a quick recap. We know that this was X, this was X, and this was X. So, and what we just solved, and the reason is they say hence. So using what you just solved, now do this. So because we have to use what we just solved, which was B1 plus B2, we now need to determine X. So that gave us a bit of a hint that we need to be working in this triangle. So let's see what we have. We're going to have that B1 plus B2 plus X for the C2 plus this X for D3 is equal to 180 degrees. And the reason they're all in this triangle. They're all in the same triangle. So this is angles in a triangle. So, but I just solved what B1 and B2 is. I know that's 133 degrees. So I have that 133 degrees plus 2x is equal to 180 degrees. So I just take over that 133 to the other side, and I'll end up getting that 2x is equal to, if I put that in my calculator, I get 47 degrees. So I end up solving that x is equal to 23,5 degrees. Okay, so I know normally you never solve for an x to be a fraction like 23,5. Normally it's 23 or 24 degrees. But in this case, trust yourself, trust the theory, and stick with the process, because I know this is a bit unusual for them to like not leave the answer in a nice rounded format. But yeah, trust the process over there. In question 6, we're given this diagram, and it says that A, B, C, D, and E lie on the circle with center O. So again, there's valuable nuggets of information there. We have center O, so we know that OA and OE are equal because they're both radii. And additionally, A, B, C, D lie on the center of the circle. So we know we can create cyclic quads with that. So in the previous question where I could create a sketch or construction, I can also create a construction here to make a cyclic quad if I would like to. So that might come into handy a bit later. So we're also given that AC is perpendicular to OB. So that's given here by this right angle triangle over here. So AC is perpendicular to OB and they intersect at F. OA is a straight line. So AOE rather, AOE is a straight line. And A1 is 38 degrees. So again, very important. This A1 is equal to 38 degrees. They haven't shown that this is 38 degrees. So it's really important we read that information so we don't miss that, because we're obviously going to need that later. Okay. Now we get into the questions, and again, reasons for statements. It says there at the top. So we need to determine C1. So C1 is over here. So we need to determine this angle over here. But they said that AOE is a straight line. So this is a straight line. And you'll see that's a diameter. So AOE is a diameter because these are radii. So this is a diameter. So we know that C1 is equal to 90 degrees. And the reason there is angle in a semicircle. Okay. Angles in semicircle. Now we have to determine angle D. So this over here, angle D. And if you look carefully, we have a cyclic quad over here. So I'm going to trace the cyclic quad for us. Actually, I don't have to be feathering it like that, but this is our cyclic quad over here. So we have a cyclic quad. And again, all 4 vertices lie on the circle. So it's a cyclic quad. And we know that A1 is 38 degrees. So we can just use our cyclic quad theory that D, if you add these two angles, they have to be supplementary. So we know that angle D is equal to 180 degrees minus 38 degrees. And the reason is op angles. So it's op angles of cyclic quad. And we know that they're supplementary. So opposite angles of cyclic quad are supplementary. So we have that, and if we solve for that, we'll get that D is equal to 142 degrees. Now it says we have to determine angle ABC. So ABC, it's these two angles over here, ABC. Again, we have a cyclic quad that we can work with. And I'd recommend working with the cyclic quad. So this is our cyclic quad. Over here, this is a cyclic quad. And we know that B1 and 2 is, this is the opposite angle. So E1 is opposite to B1 and 2. So if we know E1, we can solve for B1 and 2. And to solve E1, we know that this is 90 degrees and this is 38 degrees. So you remember we can also use what we've just solved to guide us to solve this question. So we already solved that this is 90, so we can use that information to now solve E1. So we know that E1 is going to be, if we say E1 plus 90 degrees plus 38 degrees, we know that that is 180 degrees. And the reason is angles in a triangle. So if we solve that, we get that E1 is equal to 52 degrees. And that was the first part. Now we also know that angle ABC plus E1, angle E1 is equal to 180 degrees. And the reason here is op angles of cyclic quad. But we know what E1 is. So when we solve this, that shouldn't be there. Should be there. We know that this is now 180 degrees minus E1, which is 52 degrees. And when we solve that, we get ABC is 128 degrees. So now it's given that AC, so this entire length over here, is 8 centimeters. So the entire length is 8 centimeters. And BC is 5. So BC is 5. This length over here is 5. It says determine the length of BF. So we need to determine this length in red. So BF. So let's fill in what we know. We know that this angle is 90 degrees. And the reason there is because if this is 90, this has to be 90 because of angles on a straight line. So this is 90. We're trying to solve for BF. So it looks like some Pythag shenanigans is going on here. But the thing is, we don't know FC. We don't know this distance over here. But we can use our theory that says, we don't often use this one, but we can use our theory that says line from the center is perpendicular to the chord. And if that's the case, then we know these two will be equal. And we do. This is what we have. This is our center. Here's our line. And it's perpendicular to this chord. So this is 90 degrees. So we know that our line from center is perpendicular to our chord. So now we know that these two are equal. So we can write that. So we can say that AF is equal to FC. And the reason there is line from center is perpendicular to chord. So we know that those two are equal. And because they're equal and they are a total of 8, we know that FC is equal to 4 centimeters. So we can say that therefore FC is equal to 4 centimeters. So we know now that this is 4 centimeters over here. So we can use Pythag. So this is just one of those special triangles, the 543 triangle, one of those Pythagorean triples. But if you don't remember, that's fine. We can just use the normal trig formula. So, I mean, normal Pythag formula. So we'll have that FC is equal to the square root of 5 squared minus 4 squared. And if we solve that, we're going to get 25 minus 16, which is 9. Square root of 9 is 3. So FC is 3 centimeters. So don't forget this unit, 3 centimeters. Now here we have an interesting question. I haven't seen this one before, but we have to prove the area rule. So I did check the subject assessment guidelines. And again, if you're looking for those, you can download them on my website. There's a link in my About section on the channel. But I did find it was quite interesting that you are required to know how to prove the area rule for exam. So it is examinable rather. And case in point, your question 7 of this exam it's here. So it's definitely examinable. So we have to prove the area rule. So stating that the area of triangle PQR is equal to a half PQ sine R, sine of angle R, for any acute angle triangle PQR. So this formula is on your formula sheet, and normally we just use it, but now we're actually going to have to show the proof. So I'm going to draw us any random triangle here. So it has to be an acute triangle. So I'm going to draw this triangle. I should draw this bigger. I'm just scared of drawing. My drawing's not the best. I always feel self-conscious about my drawings. But anyways, we have this triangle, so we'll call this P, Q, and R. And we're trying to find the area of this triangle. So we know that this formula, we normally apply this formula. But the general formula for a triangle is we take the area of a triangle. So I'm just going to say the area of a triangle in general is equal to a half base times height. That's the general formula. Okay. So we're going to be using this general formula to prove this formula over here. So we draw this general triangle. And what is my height in this triangle? So remember, your height is your perpendicular height. So this is our height over here. So I'm going to be calling this h. This is our height h. So that's our height h. So we're going to be needing that. And what I'm going to do is across from this big R, this side we're going to call little r. Across from this big P, or capital P, this is going to be lowercase p. And across from this Q, this whole line is going to be Q, little q. So that's just the normal notation that we use. And we know that this angle we're going to need sine R. And there we go. So let's have a look at it. So we know the base of this triangle. The base of the triangle is just PR, but we need to determine the height. So to determine this height, we're going to be working in this little triangle over here. So we're going to be working with this triangle to determine our height h. So we can use our normal trig identities or laws. So we know that sine of angle R, so this is angle R over here. So sine of this angle is equal to opposite. So our opposite here is h over our hypotenuse, in this case, is P. So our hypotenuse is P. So we have that sine R is equal to h over P, but we're trying to solve for this. We're trying to solve for our h. So we make h the subject of the formula, and we get that h is equal to P times sine angle R. So we have that. And now what we do is we're just going to use this formula, and we're going to substitute in what we know. So we know the base, and we know the height. We just solve for the height. I'll show you what the base is in a second. So we can say that the area of our triangle, now we're going to label our triangle, it's triangle PQR, is equal to a half base times height, and a half stays a half. Our base is down here. This is our base. So it's PR, but also just little q. So we put little q, and our height we solved over here. Our height is P sine angle R. So when we rearrange this, we get this. And that's exactly what I asked us to prove. So over here, we had a proof, that is terrible. We needed to prove this over here, and we've just proved it over here. So it's in the exact same format. And we just used the base rule for area of a triangle. So this was what they call a derivation. So this is how you derive the formula. This is how you derive this formula. Now we're given this diagram, which is a solid right triangular prism with sides 8 centimeters, height of 15 centimeters as given. And it says calculate the total surface area of the prism. So surface area is when you paint the shape. So essentially it's just the sum of all the areas, the face areas of the shape. So we can write that surface area is equal to, we're going to be adding the area. So you can almost say surface area is the sum of areas. So instead of surface area, it's SA, sum of areas. But let's have a look at that. So we're going to be working with this rectangular face. So the area of that is length times breadth. So we say 8 times 15 plus this one, this face over here. But this face is also 8 by 15. So what we can do is we can just open a bracket here and we can say 2 times. Let me just double check if there's not another one. There is another one. So it's actually just 3 times this, because this face over here is 15 by 8. This one on the right is also 15 by 8. And then this one here at the back, over here at the back, is also 15 by 8. Because this distance down here is 8 and the height is 15. So we have 3 of these 15 by 8s. And now we just need to add the triangles, the area of the triangles. So what I'm going to do is I'm going to draw a separate diagram for these triangles. So the bottom triangle and the top triangle are the same. So again, my drawing's too small here. But anyway, this is 8, this is 8, and this is 8. So it's an equilateral triangle. So to work out our height over here, because we're going to be having to find the area. So this is our height. We know that this is 4 centimeters. So to work out the height over here, we're going to be saying that the height is equal to the square root of 8 squared minus 4 squared. So when we evaluate that and put it in our calculator, we get 4 root 3 units. And now if you want to find out the area of the triangle, we say that the area of the triangle is equal to a half base times height. So that's a half. Our base is this 8. And our height is over here, this 4 root 3 units. So if we evaluate that, we're going to be getting 16 root 3 units squared, or square units. So if we go back up to here to our surface area, we're going to say that shouldn't be an equal, it should be a plus, because we take our 3 rectangular faces and now we're going to be adding our 2 triangles. So plus 2 times, okay, because this is the area of 1 triangle. So this is of 1 triangle. So we have 2 triangles. So we say 2 times this area. So 16 root 3. And when we evaluate that, we get our surface area is going to be 415. So 415, comma 4 units squared. Square units. So that concluded section A. So that was the first half of the paper, and now we're heading over to section B. So there's going to be a lot more trig stuff from now on, and also we can see now from question 8. So here we have this question. We have to solve for x correct to 1 decimal place in the given interval. So you should be able to tell over here that we're going to be doing trig general solutions, but in this case it's a specific solution because they give us a specific interval. So, but we know it's under that section of work of trigonometric equations. So general solutions or specific solutions. Okay, so let us get into that. So we're given this 1 minus 2 sine squared x is equal to negative 1 over 7. So we have an identity on our formula sheet that says cos 2 alpha is equal to 1 minus 2 sine squared alpha. So essentially, what we have here that I've underlined in blue, I'm going to underline it in green now. So that we just have over here. So here they're talking about alphas and we have x's, but it doesn't really matter. So the main point is we can rewrite what I've underlined here in green with this thing on the left. So instead of this, I can write that this is actually just cos of 2x is equal to negative 1 over 7. And now I can put that in my calculator. So remember, when we do our reference angles, we ignore this minus in front. So we don't actually care about this minus in front. So I'll write what I'm putting in my calculator for us. This is what I'm writing in my calculator. I'll put it up here for us. I'm going to be writing this. I'm putting cos to minus 1 of 1 over 7. That's all I'm putting. So you'll see here, there's no negative in front. So if I do that, 1 over 7, we get 81, 8 degrees. So this is our reference angle. So this was our angle, 2x. So we have 2x is equal to 81, 8 degrees. So what I like to do is put a box around this, and we call this our reference angle. So this is our reference angle. So very important, that step that I just did there is really important. Okay, so let's have a look. We have cos 2x is equal to negative 1 over 7. So if we do our cos diagram, you should remember that cos is negative here and here. So in quadrant 2 and 3. So what we write is we say that 2x is equal to, and then to get to quadrant 2, what I say is 180 degrees minus my reference angle plus K360, or 2x is equal to, and now I need to be in the third quadrant. So what I do is I say 180 degrees plus 81, 8 degrees plus K360. All right, and then we should be saying that K is the element of integers. So if we evaluate this, we get 2x is equal to, put that in the calculator, we get 98, 2 degrees plus K360. Or if we keep working here, we're going to get 2x is equal to 180 plus 81.8. So this is 261, 8 degrees plus K360. But very important, the question says we need to solve for x. And here we have 2x. So we actually need to divide both sides by 2. And when we do that, I'm moving to a different color now. We're going to be getting 98 divided by 2. So this is going to give us 49, 1 degrees. And then also very important, this also needs to be divided by 2. We also divide this by 2. And when we do that, obviously that's just going to be K180. And same thing over here, x is equal to, I take 261.8 divided by 2 gives me 130, 9 degrees. And then also very similar, this gets divided by 2 and we get K180 degrees. Okay, so there is our general solution, but we need to answer on this interval over here. X is the element from negative 180 to 90 degrees. So we need to choose values of k. So for example, k is equal to 1, or k is equal to 1, sorry, k is 0, k is 1, k is equal to minus 1, etc. So we need to choose integers, and we're going to be plugging into this k over here to determine our x values. So we know we're going to be having some x values. So we're going to say x is an element of, and we open up a set like this. So what I'm going to work with is over here, I'm going to be setting k is 0. I'm going to see what happens. So if k is 0, this falls away, right? So this over here will fall away. And I'm just left with 49, 1 degrees. Over here, if I have k is 0, that falls away, and I'm left with 130 degrees. But that 130 doesn't fall within this range, so I don't include this 130. Okay, and now what I do, if I set k is equal to minus 1, so if I do that, I'm going to be getting 49.1 minus 180. So I'm going to be getting minus 130, 9 degrees. This fits in it fits in for us over here because it's not bigger than, sorry, it's not to the left of 180. So that fits in. And so that was for k is equal to minus 1 over here. K is equal to minus 1 over here. we say 130.9 minus 180, we get minus 49, comma 1. Okay, so we tried k is equal to 0, and we tried k is equal to minus 1. Now we have this, we're given this thing over here, and we have to simplify it into its simplest form. And we have these. So we got these 90 plus thetas, 180 minus thetas, and negative thetas. So what we need to be doing here is we need to be using our reduction formulas. So if we apply that over here, we're going to get negative cos theta. Let me just fix this. Times by. So cos 90 plus theta over here is negative. Cos is negative here. So what we do is we say negative, because cos is negative, but now we change the cos to a sine, so it becomes sine theta, and then all of this is cubed. Then we have tan 180 minus theta, so tan 180 minus theta is negative, so tan 180 minus theta, it stays tan, but it's negative over here, so what we say is minus, in a bracket we have minus tan theta, because tan is also negative over here, so tan's negative over there. And then the cos theta stays the same. And then here we have cos of negative theta, so we're over here now in the fourth quadrant, because negative angle just means we start measuring clockwise. So that actually just becomes cos theta. So that just stays cos cubed theta. Okay, I can also write it like this first, cos theta, and then on the outside cubed. Okay, so let's put together what we've got for us here. So actually this negative and that negative are going to cancel. So that's just going to be giving us, let me move to a different color actually. So that's just going to be giving us cos theta times sine cubed theta. And then these minuses are going to be canceling. So we're going to get plus, and we're going to be having tan theta times by cos to the power 4 theta. And what we can do is we can break down this tan even further. I should be putting equal signs here. There should be equals there. But if I keep rolling with this, I can simplify that tan into sine squared over cos. Sorry, sine over cos. So sine theta over cos theta times by cos. So this should be a full theta. And you'll see that these now will cancel. So these will simplify and I'll be left with a 3 up here. So let's move to a different color. So when I do that, cos theta sine 3 theta plus sine theta cos 3 theta. So that's what I've got going for us over there. And now what I can do is I can take out a common factor. I can factorize. So if I do that, I'm going to be getting cos theta sine theta. That's our highest common factor. And then I'm left with sine squared theta plus cos squared theta. And then obviously we know that this is equal to 1. So we're just left with cos theta times by sine theta as our final answer. In question 9, we're given this circle, and it says that ABD and origin O lie on a circle with center C. So ABDO lie on a circle with center C. So C is our center. The equation of the circle is given by this equation over here. And the equation of line AB over here is also given. So we know the equation of the circle and we know the equation of the line AB. So very important. What I would identify here is we can immediately solve for A and B because we know the equation of this line. Okay. So again, my drawing is not so good. Sorry. We know the equation of this line. Let me fix this. We know the equation of this line AB. But we also know the equation of the circle. We know the equation of this circle. So what do you notice at points A and B? A and B are the points of intersection of those two lines. So again, we haven't even looked at the questions, but we've deciphered some things about that. Okay. In this case, we don't have radii because this is the center. So don't be confused. AD is not a diameter because it doesn't go through the center of the circle. Okay. So we've deciphered all of that. Let's get into the question. We have to determine the center and radius of the circle. So we're going to have to be working with this equation of a circle, and we're going to have to be completing the square. So I know a lot of students struggle with completing the square, so I'm going to be giving a bit more focus onto that in this example. So hopefully that will clear some things up. Okay, so we're going to have to complete the square, and the reason is we were trying to get it into the standard form. We're trying to get the circle into its standard form. That's at the bottom of page 1 in your formula sheet. You'll see it in a second. Okay. So what I'm going to do first is I'm using our equation at the top right over there, but I'm going to put all the like terms. Well, not the like terms. I'm going to put the x's together, and I'm going to be putting the y's together like such. This is equal to 0. So what I want to be doing now, the whole essence of completing the square is I want to have a bracket here that is going to have x in it. And I want to have a bracket in here that's going to have a y in it. And they're both going to be squared. So that's what I want to create. But the problem is when I do that, I create some extra numbers that weren't originally here in this line over here. So in line 1, for example, let's call this line 1. So when I complete the square, I'm actually fabricating some numbers that I have to do the opposite of. Okay. So the rule is here, I need to be having a bracket with x. And now what I do is this is a plus. I'll put a plus here. And now what I do is this was a 3, so I half this. So half of 3 is, so half of 6 is 3. So I've just put that 3 there. So it's just as easy as that. But now what did we create? If we say 3 squared, we've created a 9 that wasn't there before. So to take away the 9, what we do is we say minus 9. Okay. So we say minus 9. And then very similar with the y's. We were working with y, so we put a y here first. And then here we half this. So we keep the sign, it's a negative. Then we half this 8, and we put a 4 here. And when we do that, we say, okay, hold up. What did I actually create here? If you take negative 4 and square it, you've created a 16. So we need to take away a 16. And this is all equal to 0. So we've created some extra numbers, so that's why we're minusing over here. And then if we continue on with this line, we're going to be getting that x plus 3, that should be x plus 3 squared, plus y minus 4 squared is equal to, this will give us 25, but 25 is just 5 squared. And now it's in the exact form that we need to determine the center and the radius. So the center is just, we change the signs over here. So the center now is just, the center is given by this coordinate C. So we say the center C is given by, instead of plus 3, we say minus 3. And instead of minus 4, we say 4. So this is the center. And the radius is equal to 5 units. So be very careful. This number on the right, this number here on the right is 25. It's the radius squared. So to determine the radius, we take the square root of this. So that's why it's 5. That's why the radius is 5. Okay, so that's all we needed to do here. I hope that this, if you were struggling with completing the square, I hope that this was a bit enlightening for you and it helped a bit. Okay, so now, whoa, lo and behold, question B says determine the coordinates of A and B for 6 marks. So let's not panic. We just need to work out the coordinates of A and B. So what we do is we just set the two graphs equal to each other. Well, the two functions. So the two equations are given by this one above and this one below. So those are our two equations. So let's work with the equation of AB. So I'm going to write it first. X minus 2y plus 21 is equal to 0. So we have two equations and two unknowns. So what we're going to have to do is simultaneous equations. So what I'd recommend is we make x the subject of our formula here. So we're going to get 2y minus 21. So this is our formula, and we're going to substitute this x over here. We're going to be substituting this x into this equation over here for the circle. So I'm going to write the equation for the circle first with the x's. So this is what they gave us originally. So this is what they gave us, but now I know I can replace x with 2y minus 21. So I'm going to do exactly that. So by this x, I'm going to say 2y minus 21. So be very careful. Make sure you open a bracket like this. Plus y squared plus 6. And my x is now 2y minus 21. And I say minus 8y is equal to 0. So when I do this, I'm going to be using the short method, but you can write this bracket out twice. So you'll be getting 4y squared times these together. I'm going to cheat a bit and look at the memo. So this is minus 84y plus 441. Sorry, 441. So 441 plus y squared plus 12y minus 126 minus 8y is equal to 0. So if I collect my like terms over there, I get 5y squared minus 80y plus 315 is equal to 0. So I can use my calculator to solve this, or I can just use normal factorization techniques. I'm going to assume that you use your calculator to do this. I will be making a video on how to solve these questions, these trinomials, factorized trinomials using our calculator. I did show it in the previous video, but I will make a separate video. But anyways, when you, whatever method you use to solve for this, you'll get that y is equal to 7 or y is equal to 9. So we get two y values. So what we need to do now is I'm going to be calling this equation 1. We need to take these two y values and plug them back in here into equation 1. So in this position here. So whenever you see y, we're going to replace it with these two. So what we do is we separate these two, and I'll have that x is equal to 2y. So 2y minus 21. Again, I'm just plugging into equation 1. And when we solve that, we get x is minus 7. And on this side, we're going to be getting x is equal to 2 times 9 minus 21. And when we solve for that, we're going to be getting minus 3. So we're not done here because we needed the coordinates of A and B. So we need to determine which one is which. So A is closer to 0 and B is further away from 0. So we know that this one is A. So A is given by these coordinates, and we know that this one is B then. So minus 7, 7. So always remember to leave that in coordinate form. Now we need to determine the midpoint of AD. So here's A and here's D. And to determine the midpoint, we need the coordinates of A and D. So we know the coordinates of A. We just solve that A is minus 3, 9. But we don't know the coordinates of D. So we're a bit stuck here. But what do we notice? What's special about D? So D is a point of intersection of the equation of the circle. So the circle intersects the x-axis at D. So we know the y value at D is 0. So what we do is we use this equation of our circle, but we know our y value is 0. So we solve for the x-intercepts using this equation. So when we do that, we're going to be getting x squared plus 6x is equal to 0 because the y's all fall away. And we just factorize this is equal to 0. So we know x is equal to 0 or x is equal to minus 6. So we know D must be the minus 6 one because the 0, 1 is there. So D is the point minus 6, 0. And we should write that here. So therefore D is the point minus 6, 0. So to determine the midpoint of the two, what we do is we just use our midpoint equation. So we can say that the midpoint of AD is equal to, or not equal to, we normally just draw a bracket like this, and we add our x's. So we say minus 3 minus x over 2, and we add our y's. So for that, we say 9 plus 0 over 2. And when we do that, we find that midpoint AD is given by minus 9 over 2 and 9 over 2. So that's our midpoint. You can leave it in fraction form, or you can put it in decimal form if you prefer. Now, an interesting one, we have to determine whether CB passes through the midpoint of AD. So we know that the midpoint of AD is over here, and we know that it is the point minus 9 over 2, 9 over 2, the midpoint. And we know the coordinate of B. So the coordinate of B is, let's go back and check. Where was it here? Minus 7 and 7 here at the bottom. So the coordinates of B is minus 7 and 7. And the coordinates of C was just our center of the circle. So minus 3 and 4. Minus 3 and 4. So we need to determine whether CB passes through the midpoint of AD. And let's just call this, let's call the midpoint, let's give it a name, or letter rather, let's call it P. So we need to determine if CB, the line CB goes through P. So this is what we call collinear. So we need to determine if they're collinear. We have to test collinearity. So to do that, we first need to check the gradient of CB. So we go all the way the long distance, so from C to B. We need to check the gradient. So the gradient of CB, so the gradient of CB, if we do this, we're going to be getting 4 minus 7 over minus 3 minus negative 7. So that becomes a plus 7. And when we evaluate that, we get that the gradient is negative 3 over 4 for CB. Now we do the same for CP this time, the gradient of CP. And when we evaluate that, we're going to be getting 9 over 2 minus 4 over negative 9 over 2 minus negative 3. So that becomes a plus 3. And when we solve for that, this gives us negative 1 over 3. So because these gradients are not collinear, you can say that therefore not collinear. And the reason is because the gradient of CB is not equal to the gradient of CP. So therefore CB does not pass through the midpoint. So a second circle was drawn and is given with this equation. It's drawn on the same set of axes. A student claims that the two circles touch each other in one point. Is the student correct? So whenever we're dealing with two circles like this and are they touching, what we have to be doing is you're always dealing with the distance between the centers. So we need to find out the distance between the centers. So if the distance between the centers is the same as the sum of the radii, then they will touch. So they will touch. So you can think about it like this. If I have a circle here and a circle here, so it looks like two eyes. Okay. So the distance between the centers is this. Okay. Let's say the distance between the centers is 15. Okay. But the sum of the radii, let's say this is 5, and this is 5, and this is 5. So you see, if we sum the radii, so if I say here the distance is 15, but if we sum the radii, we get 5 plus 5, which is equal to 10. So because the sum of the radii is not equal to the distance between the centers, we know they don't intersect. So when the distance between the centers and the sum of radii are equal, then the circles do intersect. So, and at one point only. So we need to check that fact. So we need to find out the distance between the centers. So we know the center of our old circle, where did we work it out? Was over here. So we have the center was negative 3, 4. So I'm going to be writing that for us. The other center equation, or coordinate rather, was negative 3, 4. The center for this one is, let's call it K. The center K is 3, negative 4. Okay, so we need to work out the distance CK, or the distance between the centers. We just use our distance formula. So if we apply that, we get minus 3 all squared plus 4 plus 4 squared. If we put that in our calculator, we get that the distance between their centers is 10 units. So that's the distance between the centers. And the sum of radii is equal to, so this radius is 5 squared, because remember this should be r squared over here. So we know that the radius is 5, and we know from our radius from our other circle was also 5. Let me show you. And it came from over here when we determined the radius was 5. So we know the two radii. So 5 plus 5 is 10 units. So what we can say now is, we can say that the student is correct because that's a question. So we can say, therefore, student is correct. And the reason is the circles will touch, because the circles will touch or intersect. Okay. And the reason is because the distance between the centers is equal to the sum of the radii. Now we're given a door. It's a closed door. ABCD is a closed door. So the thing in this light blue in the background is a closed door. So it's 1,2 meters wide and 2,2 meters in length, so 2,2 meters tall. When the door is open 42 degrees along the hinge AD, so this is here at the bottom, when it's open 42 degrees, its new position is represented by just this blank thing here in the front, this blank door. Okay, so again, let's fill in some things we know. We know that this is a rectangle, it's a rectangular door. So this is 2,2, and here at the bottom, this is 1,2. Okay, so we know that as a fact. We know this distance across is 1,2, because it's the same door, it's just open now. So this distance down here is 1,2, this length stays 2,2, but then this one here on the side is 2,2. So we might need those facts, so we put those in. Okay, I might have to redraw those now on this new slide, but anyways, the only question here is determine the size of angle FAC. So we need this angle over here, FAC. So let me get us here in the big picture. So we need this angle over here, FAC. So I want you to imagine there's this like slanted triangle. Again, I'm terrible at drawing, but let me trace it rather. They want this slanted triangle, if you're with me. They want this angle in between. Sorry, I'm so bad at drawing. They want this angle here in the middle. Okay. So I hope that was clear, my scribblings. Okay. So they want this angle FAC. So we're going to have to be doing some trig stuff over here. So again, let's fill in what we know. We know that this is 1,2 down here. This is 2,2. This is 1,2 across because it's the same door. This is 1,2 again. This over here is 2,2. So we need to be working in this slanted triangle. So we need to figure out some stuff in that triangle. So what we notice is this length AC, we're going to need this length AC. And we notice it's actually just the diagonal of the door. It's just the diagonal of the door. So what we can do is we can just do trig over there, and we can determine that AC, we work out AC. So we use trigonometry and we can, Pythagoras' theorem. So we know that AC is equal to the square root of 1, 2 squared plus 2, 2 squared. So when we do that in the calculator, we get 1, 2 squared plus 2, 2 squared. And we get that this is, I'm going to leave it in its unrounded form because we're probably going to need it in a second. So it's root 157 over 5 units. Okay, so we know what that length is over here. So I'm going to fill it in is, we know what this is. So it's root 157 over 5. But this, on the other side, it's the same door. All right, so it's the same diagonal. It's just moved in a different position. So its length hasn't changed. Like if you open the door, its diagonal doesn't change. So this length over here is also root 157 over 5. So we're almost golden, right? Because we have these two sides. If we can get one more side, we can determine we can use the cos rule to determine this angle, FAC. So basically what we're saying is we need this length FC now over here. So we need this length FC. So let's have a think how we can do that. We have this triangle over here going for us. At the bottom, we have this DCF triangle. Let me draw this DCF triangle for us. So this is the DCF triangle, DCF, and we're trying to work out this FC distance. So we know that this is 1, 2, 1, 2. And what I notice now, this isn't actually units because they've given us a distance. So sorry if anyone was angrily typing in the comments. This should be meters. Okay, I just realized that. So this is 1, 2 meter, 1, 2 meter. And we know this angle in between is 42 degrees. Sorry, I ran out a bit of space. So we can use the cos rule here to work out FC. So when we do that, we're going to be getting that, we get that FC squared is equal to 1, 2 squared plus 1, 2 squared minus 2, 1, 2, 1, 2, and then cos of that angle, 42 degrees. So if I analyze all of that, I should be getting that FC is 0,86 meters. Okay, so FC is equal to 0,86 meters. So yeah, again, let me go through the steps. So if I put this in my calculator, 1, 2 squared. So if I get that FC squared is equal to 0,7397. And now I have to square root to find FC. So when I square root, I get FC is equal to 0,86 meters. Okay, so now I have everything I need to solve for FAC. Sorry, angle FAC. So I'm going to draw that triangle that we're going to be working with now. So it should look something like this. We know what these diagonal lengths are. So this diagonal was the diagonal of the door that we use Pythag to find, and it's the same diagonal even when it's open. The length doesn't change. So those are those sides. And we just worked out FC to be 0,86. And now we can find this angle because this is the angle FAC that we're trying to find. So we're going to be writing out the cos rule. We're going to be having that 0,86 squared is equal to 157 over 5 squared plus square root 157 over 5 squared minus 2 157 over 5 square root 157 over 5, and then cos of FAC. So when you evaluate this and you put it all in your calculator, let me show it again. So, well, yeah, when you put this all in your calculator, you should be getting that cos FAC is equal to 0.9411 and a few decimal places, remember, don't round. And then when we solve for angle FAC, so FAC, yeah, we just use the shift cos. And when we get that it's about 19.8 degrees. So not too difficult of a question. We just need to break down all the information that we need about that diagonal and stuff. So actually, it's a bit more challenging of a question. But once you have the information, it's not that difficult. You with me? I hope you understand what I'm saying. But what is a bit confusing is things like this, getting an AC of this value. It's not a nice number, but it looks very bad, right? It doesn't look like you're on the right track, but trust yourself. You've applied Pythagoras properly, and that's what you got. So just trust yourself. So yeah, in hindsight, or rather, let me correct myself, it was a more challenging question, but because we had to break down these steps that were challenging. But the initial steps were quite simple. We've just used Pythag, cos rule, cos rule. Now going from that to proving identities. So we just deal with left-hand side and right-hand side rules. Not rules, but we deal with the left-hand side, try to make it equal to the right-hand side. So my rule of thumb here is we need to convert. We know things need to be converted into other things. So what I do is I look at this, for example, sine 2x. I need to decide, I see already that I'm given this form here at the bottom. So I know sine 2x is the same as the thing at the bottom. So I need to convert the sine 2x to look like the bottom, because I want all the things to look the same, because I need to get them in the same orientation. Okay, so my steps are just to convert. Okay, let me show you. So left-hand side we're rocking with here. So I'm going to convert this thing here at the top. So I use my formula sheet, and I'll see that sine 2x can just be written as 2 sine x times cos x. So you see how this looks exactly like the bottom already. You with me? Okay, plus sine squared x minus cos squared x. So we've made this one conversion. Let's not get ahead of ourselves. Let's roll with this one conversion. And then let's look what else we can change and convert. Okay. So we see that the top is in a weird format. If this was sine squared x plus cos squared x, we know that's just 1. But we don't have that. So it's a bit problematic. But if we look here at the bottom, we have an identity for this. It's on our formula sheet. So let's convert this so it looks like the thing at the top. All right. So again, we're just taking it step by step and doing one little convert by one little convert. So the top stays exactly the same. But now I'm going to rewrite this cos 2x, and I'm going to write it as cos squared x minus sine squared x. So now everything's in the same format over there. So now, again, we're dealing with some problems because these top and bottoms aren't the same. So now I need to be thinking about how can I need to cancel something because things aren't looking not so bueno right now. Things aren't looking so good. So what we need to look at now is we've converted and everything's more or less the same, but there's some issues. But I need to be thinking about, I need to get rid of this sine squared x and this cos squared x. So I need to be looking at these ones. So I need to convert these ones into sine squared x plus cos squared x. So let me show you with that. So this now becomes sine squared x plus cos squared x. So the 1 changes. And you'll see here in a moment why this is an important change. You see here, I have a minus cos squared x. So they're going to cancel. The plus cos squared x and this minus cos squared x. So I'll show you the cancellation in a moment as well. And then at the bottom, I make the same conversion. And you'll see now what's going to happen is this cos x is going to cancel with that one. And at the bottom, the sine x squared is going to cancel with that. So what I'm left with is at the top, I'm left with 2 sine squared x plus 2 sine x cos x over 2 cos squared x plus 2 sine x cos x. Okay, so I'm going to start working here on the right now because I'm running out of space. But what I do now is I just take a common factor. So my common factor at the top is 2 sine x. And what I'm left with is sine x plus cos x. And at the bottom, if I factorize the bottom, I'm going to be having 2 cos x. And what I'm left with is cos x plus sine x. So these two things in the bracket are exactly the same. So these will cancel. These 2's are exactly the same, so they'll cancel. And what I'm left with is just sine x over cos x. And again, I should be putting equal signs there. And that is just equal to tan of x. So therefore, the left-hand side is equal to the right-hand side. Okay, this was quite a difficult identity to prove, but I hope me breaking down the steps and how we convert every time helped make it a bit more clear. But again, it was a difficult one, so if you struggle for this, it's normal. Okay. Now, we have to use what we just did, and we have to determine the values of x for which the identity given in A is not valid. So I've repeated it here in the top right for us. We need to find where this identity is not valid. So the identity is not valid when our denominator is equal to 0. So if you have a look, this is our denominator, this step over here. So when our denominator here is equal to 0, then we run into issues. So I'm going to rewrite our denominator. It's 2 cos x plus sine x. That's our denominator, and the identity will not be valid when this is equal to 0, because then it will be undefined. So we have two cases here. We're going to be having that 2 cos x is equal to 0, or cos x is plus sine x is equal to 0. Okay, so what we're left with here is just cos x is equal to 0. So what I do here is I just take the cos x across, and I get negative cos x. Then what I do is I divide both sides by cos x, and what I'll get is I'll get sine x over cos x is equal to minus 1, but sine over cos is just tan. So I'll have that tan x is equal to minus 1. So what I do now is I do my reference angles. So if I do this for cos, I'll get that my reference angle is equal to 90 degrees. So that's my reference angle. And over here for tan of x, if I do this for my reference angle, remember we only take the positive value. So we can ignore this minus. So for my reference angle here, I'll be getting x is equal to 45 degrees. Okay. And now what I need to do is I need to work out these solutions. So if I look here where cos is equal to 0, cos is equal to 0 at 90 degrees and also at 270 degrees. So I can say that x is equal to 90 degrees plus K360, or x is equal to 270 degrees plus K360, because that's where cos is 0. It's 0 up here at the bottom, at the top at 90, and also down here at 270 degrees. So I have that over there, and on the right, my reference angle is 45, and tan is negative over here and here. So what I do is I say x is equal to 40. So I say it's in the second quadrant. So I say 180 minus 45 degrees plus k, careful now, 180, because we're working with tan. Or x is equal to, and now I'm dealing with the fourth quadrant. So I say 360 minus 45 degrees plus k 180. And then remember, I need to be saying that k is an element of integers. So because they don't ask for a specific solution, because there's no interval, we can leave our answer just like this. So what I forgot to do is we need to actually put this in our calculator, and we find that it's 135 degrees plus k180, or x is equal to, this will give us 315. Yeah, so this one gives us 315 degrees plus k180 degrees. So again, we don't need to give a specific solution because they don't ask for one. There's no interval, so we can leave our answer like this. Before we start question 12, I want to just have a bit of a cautionary note here. So the way I learned in school is different to the way the memo is. So let me just say the memo is being very pure, is being very rigorous here. So it's the way I'm doing here is different from the memo. So if you're following along in the memo, you'll notice it's going to be different from the memo. So the way I learned in school is different from the memo. And again, when I tutor matrics, they are also learning in a way that's different from the memo. So that's why it's a cautionary note. What I'm teaching here is not 100% in agreement with the memo, but I'm saying memo a lot. But if schools are teaching it, IEB schools are teaching it, in my opinion, unless the school has no idea what they're doing, and the students I go to really good private schools, I highly doubt the schools are teaching an incorrect method. So the method I'm showing here is what some IEB private schools, good schools, are showing, but just a note, it is different from the memo. Okay, so that was just a little side note, and I hope you're not too scared. You'll see it, it'll be okay. Okay, so we're given triangle ABC. It's given with E and G on AB, and D on AC, with AG is equal to GB, ED is parallel to GC, and they say F is a point on CG, and D on AC, with DF is parallel to AB. So that sounded like Greek to me while I was saying it, but let's break down what's going on. So in this section, I know before we always said there's so much important information. Here there is really important information, but all of this F is on CG and D on AC is not as important. So don't try to split hairs on this wording over here. Let's just have a look. AG is equal to GB. So AG is here and GB is down here. So we know that this is equal to AG. So the entirety of AG. Okay, so here I'm not showing EG, I'm showing that it's AG. So they didn't show that, so we need to add that information. They say that ED is parallel to GC. So here's ED and here's GC. Okay, so they've given us that. That's all good. Then they say that DF is parallel to AB. So here's DF and here's AB, and they're parallel. So they've shown us that. So everything's all good there. So what I'm going to do is I'm going to re-add this information that these two are equal. And now we can get into this question. We need to prove that CF over FG is equal to GE over EA. All right. So this section is super important to use different colors, and you have to be like moving your head and using different colors. You need to really be picturing things in different ways. This is a very visual section, so you need to be. It's a tough section if you don't have those skills, but just make sure that you are trying and thinking about it visually. So you need to be seeing different triangles, big triangles, and etc. So different triangles you need to be seeing. Okay, so let's have a look. CF and FG. So here's CF. Okay, here's CF, and here's CG. Okay, so if you look at that, we have this triangle. I'm going to draw it for us. It's ACG. So this triangle is what we're working with now. So here's A, C, G. That's a G. Okay. So we have this line over here. It's parallel to this line. Okay. So that's why I work with CG over, sorry, this is CF. This is an F. So CF over CG, I'm working with over there, is equal to GE over EA. So that is not what we have going for us here. Okay, because let me use a different color. Let me neaten up this diagram. I'll be right back. Okay, so we got this diagram going for us now. So we know that CF over CG, we need to prove that, let me fix that, CG, we need to prove that CF over CG is equal to GE over EA. So we would expect that because we're working with this parallel line, so you see we go here up until F, so that's parallel line, and then we go there to that parallel line. So we expect to do the same. So we go to the same parallel line, and then we go over to the other side. So you see how it's the same. So if we were working normally, what we would have is we would have that CF over FG is equal to, and this is D over here. Let me add that in. This is D. So normally what we would have is this over CA if we're working with this triangle, but we don't have that. So somewhere there's going to be another triangle that's going to be like a middleman, okay? That's going to help us figure this out. So what we need to be doing is we have to look at the other triangle. So I'm going to draw the other triangle for us. So in this triangle, CD is here and CA is over there. But in this case, if we do the same principle, if we go from G to E, so this parallel line, and we go G to A, what we should be having is we should be having that CD over CA is equal to, and in this case we have GE over EA. Okay, and let me just include the reasons. Here we say line is parallel to one side of triangle. And we need to be saying what parallel lines we're working with. So in this first case, we're working with parallel lines. What did we have there? We had DF is parallel to AG. And over here, I don't know why I've crossed up these colors, but over here, again, same reason, line is parallel to one side of triangle. And now what we're working with is we're working with parallel lines ED and GC. Okay, so I hope you can see these different triangles. So this is what I was talking about in the beginning. We have these different triangles that are super important that we can see them. There's different triangles over there, and the ratios are different. Okay, we always have to go from a side to a parallel line and like that. So we need to be looking at the different triangles with the different parallel lines. Okay, so I hope you can see that. All right. So what's important to note is here is CD and CA, and over here is CD and CA. So if CD over CA is equal to GE over EA, and CD over CA is equal to CF over FG, then I know that CF over FG is equal to GE over EA. So in this question, I repeated our two triangles for us, so we can reference them. And let's see what we're given. We're given that CF over FG is equal to 2 over 1. And now we have to determine the ratio of GE over GA. So we need to be working over here GE and GA. The problem is there's no connection between this triangle here at the bottom that we have this ratio for, because we have CF over FG, so it's this triangle. There's no connection between that triangle and and GE. So what we need to do is we need to use what we had before, where CF over FG is equal to GE over EA. So I'll write that for us. So we know that what was this? GE over EA is equal to this. We know that it's equal to this. So because these two are equal, we know that GE over EA must be 2 over 1 as well. So we know what GE over EA is. So here we know that GE over EA is 2 over 1. So let's fill that in. We know that GE is 2 times some constant, 2k we can call it, and so GE over EA is 2 over 1, so that this means this must be 1k, because 2k over 1k is 2 over 1. So k is just some proportionality constant, so it could be 10. So GE could be 20 units, and EA could be 10 units, but then it's still 2 over 1. So we put this 2k and 1k over there. So I know that GE is 2k, and EA is 1k, because over here, this is 2 over 1. So no, GE is 2 and EA is 1. So I just say 2k and 1k. So that makes GA is 2k plus 1k, because these are right next to each other. So I know that GA is 3k. So I know that GE over GA is equal to GE is 2k and GA is 3k. So no, that is just 2 over 3. So the ratio of GE to 2A, so to GA, so I can say therefore GE to GA is in the ratio of 2 to 3. Now what we have to do is we have to determine the numerical value of DF to the ratio of AB. So the ratio of DF to AB. So let's have a look. Here's DF. DF is over here. And we need to work back from DF to somehow get to a connection of AB. So let's have a look. DF is actually equal to EG. And the reason is this quad over here, EDFG, is actually a parallelogram. So the opposite sides are equal in a parallelogram. So this and that are equal, and this and that are equal, because those sides are parallel. So what we can say is we know that DF is equal to EG. So we need to continue and find a connection between EG to AB. So let's have a look. Here's EG. And we need a connection between that and this whole big thing. Okay, but if we look at this top triangle, we know that we have a ratio between GE and GA. So, and also from the previous question, we have a ratio. So what we can say is EG. So the previous question here says GE, but GE is the same as EG. Okay, I'm going to say EG over GA. So I can either use the previous question or use my triangle up here. So I have EG is 2k. I'll put 2k. And GA is this big one, 3k. All right, so these k's will cancel. So I'll be left with EG is equal to 2 over 3 GA. But here I still don't have a connection between DF and AB. So I need to go further. So I have this connection now between EG and GA. So I know the connection here between EG and GA. So I have this connection with GA, but now I need to relate this connection with GA all the way to AB. But the thing is, I know that GB is equal to AG. So I know that AG is equal to GB because it was given here in this step. So what I can do is I continue with this, but I know that GA is just equal to a half of AB because GA is 1/2 of the entire length AB. So it's 1/2 of that. So I have that EG is equal to 1/3 AB. So finally, what I can conclude is I know that DF is equal to 1/3 AB. So therefore, I have DF over AB is equal to 1/3. So finally, therefore, I know that DF in the ratio to AB is in the ratio of 1:3. So it's equal to 1/3. Okay, that was a lot. So here we're given a circle. It says it's a circumscribed circle for triangle BCF. So that's this triangle over here. So we're just given a circle. It says AB and AC are tangents to the circle at B and C respectively. So I know that AB is equal in size to AC because it's tangent from same point. So that might be useful. So that's what I got from the first bullet point. And it says FE, FG, and FD are perpendiculars from F to AB, F to BC, F to AC. So they just gave us these perpendiculars over here. So these perpendiculars. Okay, let's have a look at the first question. We have to prove that triangle FEB is similar to triangle FGC. So we're working with these triangles over here. So that's the one triangle, that's FEB, and FGC is this triangle over here. I'd recommend you do something similar to this in your tests or exams, just so we know what we're working with. So to prove similarity, we have to be working with angles. So we need to prove that, well, we only need two angles. We need to prove that two angles in the separate triangles are equal because the third triangle will be given. Okay, so let's have a look. We know that this angle here, this is a 1, this is a G1. We know that this angle G1 is equal to 90 degrees. Okay, so it's given. We also know E2 is 90. So what we can do is we can say that angle E2 is equal to angle, this should be a G1, which is equal to 90 degrees. And this was just given. We were given that they were both 90. Okay, so we need to find out some other angles that are equal. So let's have a look here. We have tangents. So this B1 is equal to C2. And the reason is tan chord, because if we go across to this chord and we go all the way to here, we see that they're equal. So we have that B1 is equal to C2. And the reason is tan chord theorem. Okay, so we only need to prove two things, and the last one will be given. So we can just say, therefore, triangle FEB is similar. So we draw these three lines like this, is similar to triangle FGC. And the reason is angle, angle, angle. So now for question B, we have to prove that FG squared is equal to FE times FD. So hidden in here is some ratio. Okay, there's some ratio of sides hidden over here. So let's have a look. We've just proven that two triangles are similar. So I've put this over here. We've proven that triangle FEB is similar to triangle FGC. So let's use this information. So I know that FG over FE are going to be equal. So let me write that for us. I know that FE over FG, or other way around, are equal. And the reason here is because of similar triangles. Okay? Similar triangles. Okay, so this was from part A. I've proven this. Okay, so I know one of my ratios is going to be FE over FG. Okay, because I already have this from A. So when I do that, what am I left with? Okay, so you would have seen that actually we have FG times FG is equal to FE times by FD. Okay, but I know one of my ratios is this over here. I know one of my ratios is this. So I'm going to rearrange this equation so I get one of these. So I just divide this left side by FG. So what I'm left with is FG is equal to FE over FG times by FD. Okay, so I can see I've got this thing that I wanted here in the circle. So I've got that. So what I can do now is I just divide both sides by FD. So I get FG over FD is equal to FE over FG. Okay, so that's essentially what I need to prove. So this is all just intro work. This is what I need to prove. So I know where this comes from, this FE over FG. I know where this comes. This comes from my similar triangle. But this thing over here, I'm like, whoa, where is this thing coming from? Where can I get this? So to get this ratio, I have to do another similar triangle. So I have to do a similar triangle where I'm dealing with FG. So I need to be dealing with this side, and I also need to be dealing with FD. Okay, so what I'd recommend is we're going to have to prove that two triangles are similar. So we know that one of them is going to be FG something is going to be similar to FD something. Okay, because we know that from this question mark. This has to be true, okay, because we're going to have FG and FD over here. Okay, so we know this is what we're aiming for, that these two triangles are similar. So let's have a look. Where do we have FG? Here's FG, okay? So we have previously proven that FG is similar, this triangle FGC, this one over here, is similar to this triangle. We proved that in A. All right, so we did prove that. But now what I need to be doing is I need to be dealing with this triangle. So I know it's this triangle. If for this triangle would be FDC. So I know this triangle is FDC because that's the only triangle that has FD in it. But this triangle with FG is a bit ambiguous because I have two triangles I could possibly use. So I could either use this one here at the bottom, triangle 1, which I've already worked with, or I could work with this triangle up here because you see they both have this FG in common. But what I need to ask myself is which one will be easier to prove similarity? Okay, because I have two options. I have triangle, this one is triangle FGC, and this one is triangle FGB. Okay, so these are my two options. So, sorry, I said B, but then I didn't write B. This should be FGB. So those are my two options, okay? So I can either work with this triangle or two. So this can either be a B or it can be a C. Okay, it doesn't matter because I still have that FG. But which one will be easier to prove similarity? So I need to ask myself that question. So I'm going to be clearing some stuff here so we can see what's going on. So let's assume I choose this triangle and this triangle over here. Okay, these two triangles. So I know that this is 90 and this is 90. Cool, golden. I need one more angle. And you'll see it's quite difficult to find an angle that is the same between these two to prove that they're the same. Okay, so that's why I would not recommend FGC. But let's have a look if we work with triangle FGB. Okay, so we know this is 90, that's 90, so we're golden. But now we need one more angle. But let's have a look here. We have a tangent. So we have this angle here, and it's equal to B2 because of tan chord. So that's why it is very beneficial that we prove this. So actually we're required to prove this. We're required to prove this to then get this. Okay. So again, this is all intro work that we're thinking, but it's quite a challenging question. Even I did struggle a bit with this, but this is all intro work for us to determine what we actually need to do. Okay, so I hope you are not too lost, but let's get into the thick of it. All right, so I need to prove that these triangles are similar. So I'm going to say in triangle FGB and triangle FDC. Okay, those are my two triangles. So what do I know in these triangles? I know that D2 is equal to G2, which is equal to 90 degrees, and this was given. And also, I know that C1 is equal to B2, and the reason is tan chord theorem. So therefore, triangle FGB is similar to triangle FDC. So I know those two triangles are similar. So let's break down our ratio now, or our proportions, or our side proportions. So I know that FG over, let me write all of the side proportions. So I have that FG over, what I have, that FD is equal to, now I'll do GB over DC. So that's GB over DC is equal to, and then I go FB all the way to FC. So FB over FC. Oh, forgot to put a reason here. This should be angle, angle, angle. Don't forget that. And the reason these sides are in proportion like this is because of similar triangles. Okay, so this I have, these ratios are from my second triangle. Okay, but from my second set of similar triangles. But from my first set, I have this. So if we look at our first set, this is our first set of triangles up here. This was from part A. So if I use these ratios, I have these. So I'll put it in green for us. So we have that FE over FG is equal to, and now I'm doing, oh, the colors are a mess, but I'm doing these now. I'm doing EB over FG, sorry, GC. And then finally I do FB over FC. So FB over FC. Okay. And the reason here, important, similar triangles. Okay, but something very interesting just happened. So these are the side proportions for different similar triangles. But what do you notice here? It's the same ratio. So that means that anything here is equal. So what I notice now is I have FE over FG. That comes from here. So I got that from here. And I know this is equal to FG over FD. I got that from here. So what I can do is rearrange this, and I can times both sides by FG. So what I'll do is I'll get FE is equal to FG squared over FD. Okay, because I'm just timesing that, putting it over there. And once I do that, now I can just times both sides by FD. So finally, I get that FG squared is equal to FE times by FD. Final answer. And that's what they're needed up here. Okay, so a lot going on. It's perfectly fine if you're confused. As I said, it's a very challenging question. I struggled as well with it. So make sure you maybe even just rewatch this and have a look at when we started with our introductory steps over here. Here in question 14, we got another confusing and challenging question. It's quite an interesting question. I haven't really seen much like this. So let's just roll with it and see how we go. So it almost looks like Greek going on here, but if 2 cos 2 alpha plus sine 2 alpha is equal to r cos, and then in a bracket 2 alpha minus beta, where r is bigger than 0 and beta is an acute angle. Determine r and beta, or b. I might call it either or, so beta or b. So again, a lot going on here, right? And it's tough to determine where to start, and it's confusing, but one of my most important principles that I try to teach is the KISS principle. Keep it super simple. Okay, so let's have a look. This cos 2 alpha minus beta, do we like working with that? Do we ever have like two angle things over here? No, we never do, right? So let's try to get rid of this. So what we need to do is we need to use this formula. I'm going to put it up here in the top right for us. So to sort out this mess that we've got here underlined, we need to be using one of these identities, okay? And you'll see we're going to have to be using this one, okay? So I know over here we have 2 alpha minus beta, but remember these are just variables. This could be x minus y. So this is in a form of x minus y, but our x in this case is just 2 alpha. So fret not, okay? Let's just roll with this. Okay, let's just roll with it and apply our identity. Okay, so let's just work with the right-hand side. So we're saying we're just working with the right-hand side. Okay, so we have r over there. But what we're going to do now is we're going to expand this thing over here. So we're going to break it up like this. So we can change it to cos of our first angle, which is 2 alpha, times by cos of our second angle, which in this case is beta, cos beta. Then what we do is we say plus, and now what we're doing is we're working over here. So it's sine of our first angle, which is 2 alpha, times sine of our second angle, which is our beta. So we have this. Okay, let's keep rolling with this, and let's distribute that r. And if we distribute that r, what we're going to do is we're going to be getting r cos 2 alpha cos beta plus r sine 2 alpha times sine beta. Okay, so we've got this going for us now. But what we need to do now is, I know it's tough to see, but we need to see a connection between the left-hand side and the right-hand side. So if you look here on the right-hand, so the left-hand side, you see how we have a sine 2 alpha. And you see here, we have a sine 2 alpha, okay? And over here, we have a cos 2 alpha. And here, we have a cos 2 alpha. So let's rearrange what we have here in such a way that they're going to be equal, okay? So from the left, we have that 2 cos 2 alpha plus sine 2 alpha is equal to, so now what I meant by earlier where it's in an equal form is I'm going to move anything that's not underlined here in orange to the front as a coefficient. So r cos beta, okay, I'm going to use a different color for emphasis here, times by cos 2 alpha. Actually, this is going to be a good idea. Watch this. This is going to be good. So 2, and then cos 2 alpha. Okay, so you see I'm just rewriting this thing over here, but in a different color. And let me do the same. Let me leave this red, actually. I will leave this red. Okay, so if I roll with this, then I'm left with plus, and now I put this coefficient, so I'm going to use blue again. So the coefficient here is r sine beta, but what I was left with before on this side was this sine 2 alpha. So I'm going to try put this sine 2 alpha at the end. Sine 2 alpha. Okay, so what you should notice now is here, this is our coefficient in front of cos 2 alpha. Here, this is our coefficient in front of cos 2 alpha. And here, this is our coefficient in front of sine 2 alpha, which is just a 1. But here is our coefficient in front of sine 2 alpha. So do you see how what I've underlined here in orange and what I'm going to re-emphasize here in pink, you see how this must be equal to this, and this must be equal to this, okay? Because the numbers in front have to be equal for this thing to be true. You with me? So we have to make the left look like the right. And the way to do that is we have to, this is a 2 here in front, so this has to be a 2. And this is a 1 in front, so this thing has to be a 1. So we write exactly that. So I'm going to roll with this color now. I'm going to be saying that R cos beta has to be 2. Okay? And so that's one of them. But we also know that R sine beta is equal to 1. So we have these two things. So we have two unknowns, and because we have beta and R, but we can just solve simultaneously. So what would be the best plan of action? Let's say here we're just making R the subject of the formula. We get 2 over cos beta. Okay, so this I shall be calling equation 1. We're going to sub equation 1 into equation 2. So 1 into 2. So whenever you see an R, we're going to be replacing it with 2 over cos beta. So if we roll with this, we now get 2 sine beta over cos beta is equal to 1. So if we solve for this, I'm working down here now, we end up getting that this is tan beta, sine over cos is tan, and then this 2, if I take it to the other side, is 1 over 2. So what I can do now is I can literally just put this in my calculator. I use shift tan, and when I do shift tan of a half, I get that tan is equal to 26. Sorry, beta is equal to 26,6 degrees. So I've solved for beta, so I've got that, but now I need R. So I just put in this beta back into equation 1. Okay, so when I do that, I get that R is equal to, let me make this more clear. So I'm working over here now. So I'll get that R is equal to 2 over cos, but I know my beta now is 26,6 degrees. So if I put that in my calculator, I'll be getting R is equal to root 5. So there we go. I've determined R and beta. Okay. That was a tough one. A lot going on, a lot of colors going on, but I hope the colors helped, even though we had to take a bit of a detour in the middle there. I hope that made things a bit clearer. Okay, this paper 2 you've seen towards the end has been super challenging. Okay, so I don't want you to feel bad, but I really hope my explanations have at least been clear and helped you a bit. If you're unsure about anything, please let me know. I'm more than willing to go into more depth, as I've said before. Okay. Now, let's go into part B. So this word over here, hence, or otherwise, at least I say, or otherwise, determine the maximum value of this function over here of 4 cos squared alpha plus 2 sine 2 alpha. Okay, so what we have here is this cos squared alpha. What we had before, let me show what we had before. So from the previous question, we had this. So this is just from part A. You'll see through all the mess, I just got it from over here. So I got it from this thing over here. Okay, so we have this. The thing is now we're given this thing over here. This thing is close to being in this form. Okay, so you see it's really close. The sine 2 alpha and the sine 2 alpha are the same there. Okay, but that cos squared shenanigans in the front is giving us a bit of a problem, because here we actually have cos 2 alpha, but here we have cos squared alpha. So actually what we're going to have to do is we're going to have to use one of our identities to change this so it's a workable form for us. Okay, so instead of this cos squared alpha, we're going to have to be using this. You use this on our formula sheet. So it's in a different form. Let me write out the normal form. So the normal form says cos 2 alpha is equal to, let me check on my formula sheet. What does it say? It says that it's normally equal to 2 cos squared alpha minus 1. This is what we normally have, right? So, but we can just rearrange this and we'll get that cos squared alpha is equal to, and that will be cos 2 alpha plus 1 divided by 2. That's what we normally, so this is what we'd get because we need to replace this. So we're going to be using this, okay? And the reason we chose this identity instead of one of the others is because we have to get this cos 2 alpha, cos 2 alpha. Okay, so when we replace that, we're going to be getting 4 times by cos 2 alpha plus 1 over 2 plus sine 2 alpha. Okay, and if we roll with that, we are going to get, those will cancel, we're going to be getting 2 cos 2 alpha plus, this ends up being 4 times 1 over 2 plus sine 2 alpha. Okay, so it's very close to being in the form we wanted over here, but we're just left with a bit of an extra thing over here. So if we keep working with this, we get 2 cos 2 alpha plus sine 2 alpha plus 2. Okay, so you with me? We've got this thing over here, and you'll see it's almost in the exact same form as this. So it's it's the exact same form as this thing on the left. Okay, so I'm going to call this 1. So these are the exact same. You with me? Those are the same. Let me make this more clear. Okay. So what I'm saying is this is 1, part 1, and you see how this is 1. So these things are the exact same format. But here I've just got this extra plus 2. Okay. So I've got this in the right format. But I need to determine the maximum value. So I need to actually be determining a value for this. All right. So I can replace this 2 cos 2 alpha plus sine 2 alpha with r cos 2 alpha minus beta. So I can replace this with that thing on the right, and I'll get that it's r cos 2 alpha minus beta plus 2. So now that I've replaced that, I get this. But I know what my r is from my previous value. So from my previous question, rather. I know that the r is, from over here, I get my r is root 5, and my b is 26 comma 6. So I have root 5 cos 2 alpha minus beta plus 2. I need to be determining the maximum. I should have equal signs here again. Sorry about that. Okay. So I need to be determining the maximum value. So what is the maximum value of this cos? Okay, so I forgot to add in our beta here. So because we do know what beta is. From the previous question, it's 26.6 degrees. Okay, so I ran a bit of issues here because look at this alpha. We don't know alpha, okay? But what I've underlined here in red, how do we work out the maximum of this cos function, right? So this is just a cos function shifted in a weird way. But what's the maximum value of a cos function? The maximum value is 1. If we draw a general cos function, it goes something like this, right? This is a general cos function. And we know the maximum is here at 1. So we know the maximum here is just 1. Okay? So I can say, therefore, the maximum of this thing is equal to root 5, because this thing underlined here just becomes 1. So root 5 times 1 plus 2, which is just root 5 plus 2. Okay, so that's the end of the paper. I know the last bit was really hectic. I mean, if you look back at all the drawings and everything we've been doing, you can see it's super intense and hectic. So I'm sorry if my explanations weren't as crisp as they could be, because this was very challenging. Again, if there's any issues, if you want me to re-explain something, I can make another separate video. More than happy to do that. More than happy to address any questions in the comments. So yeah, please let me know, and I hope you guys enjoy. Thank you guys for watching.